Section 1.3, Radicals and Rational Exponents. Learning Objectives. In this section, you will 1. Evaluate square roots. 2. Use the product rule to simplify square roots. 3. Use the quotient rule to simplify square roots. 4. Add and subtract square roots. 5. Rationalize denominators. 6. Use rational roots. A hardware store sells 16 FT ladders and 24 FT ladders. A window is located 12 feet above the ground. A ladder needs to be purchased that will reach the window from a point on the ground 5 feet from the building. To find out the length of ladder needed, we can draw a right triangle as shown in Figure 1, and use the Pythagorean theorem. Figure 1. 12 feet, 5 feet, c. A squared plus b squared equals c squared. 5 squared plus 12 squared equals c squared. 169 equals c squared. Now, we need to find out the length that, when squared, is 169, to determine which ladder to choose. In other words, we need to find a square root. In this section, we will investigate methods of finding solutions to problems such as this one. 1.3.1. Evaluating square roots. When the square root of a number is squared, the result is the original number. Since 4 squared equals 16, the square root of 16 is 4. The square root function is the inverse of the squaring function, just as subtraction is the inverse of addition. To undo squaring, we take the square root. In general terms, if a is a positive real number, then the square root of a is a number that, when multiplied by itself, gives a. The square root could be positive or negative because multiplying two negative numbers gives a positive number. The principal square root is the non-negative number that, when multiplied by itself, equals a. The square root obtained using a calculator is the principal square root. The principal square root of a is written as square root of a. The symbol is called a radical, the term under the symbol is called the radicand, and the entire expression is called a radical expression. Square root of 25. Radical. Radicand. Radical expression. A. Principal square root. The principal square root of a is the non-negative number that, when multiplied by itself, equals a. It is written as a radical expression, with a symbol called a radical over the term called the radicand, square root of a. Q and a. Does square root of 25 equals plus or minus 5? No. Although both 5 squared and, open parenthesis, negative 5, closed parenthesis, squared are 25, the radical symbol implies only a non-negative root, the principal square root. The principal square root of 25 is square root of 25 equals 5. Example 1. Evaluating square roots. Evaluate each expression. A. Square root of 100. B. Square root of 16. C. Square root of 25 plus 144. D. Square root of 49 minus square root of 81. Solution. A. Square root of 100 equals 10 because 10 squared equals 100. B. Square root of 16 equals square root of 4 equals 2 because 4 squared equals 16 and 2 squared equals 4. C. Square root of 25 plus 144 equals square root of 169 equals 13 because 13 squared equals 169. D. Square root of 49 minus square root of 81 equals 7 minus 9 equals negative 2 because 7 squared equals 49 and 9 squared equals 81. Q and A. For the square root of 25 plus 144, can we find the square roots before adding? No. Square root of 25 plus square root of 144 equals 5 plus 12 equals 17. This is not equivalent to square root of 25 plus 144 equals 13. The order of operations requires us to add the terms in the radicand before finding the square root. Try it number 1. Evaluate each expression. A. Square root of 225. B. Square root of 81. C. Square root of 25 minus 9. D. Square root of 36 plus square root of 121. 1.3.2. Using the product rule to simplify square roots. To simplify a square root, we rewrite it such that there are no perfect squares in the radicand. There are several properties of square roots that allow us to simplify complicated radical expressions. The first rule we will look at is the product rule for simplifying square roots, which allows us to separate the square root of a product of two numbers into the product of two separate rational expressions. For instance, we can rewrite square root of 15 as square root of 3, square root of 5. We can also use the product rule to express the product of multiple radical expressions as a single radical expression. A. The product rule for simplifying square roots. If A and B are non-negative, the square root of the product is equal to the product of the square roots of A and B. Square root of A, B, equals square root of A, square root of B. How to? Given a square root radical expression, use the product rule to simplify it. 1. Factor any perfect squares from the radicand. 2. Write the radical expression as a product of radical expressions. 3. Simplify. Example 2. Using the product rule to simplify square roots. Simplify the radical expression. A. Square root of 300. B. Square root of 162a to the power of 5, b to the power of 4. Solution. A. Square root of 100, 3. Factor perfect square from radicand. Square root of 100, square root of 3. Write radical expression as product of radical expressions. 10. Square root of 3. Simplify. B. Square root of 81a to the power of 4, b to the power of 4, 2a. Factor perfect square from radicand. Square root of 81a to the power of 4, b to the power of 4, square root of 2a. Write radical expression as product of radical expressions. 9. A squared, b squared, square root of 2a. Simplify. Try it number 2. Simplify the square root of 50, x squared, y cubed, z. How to? Given the product of multiple radical expressions, use the product rule to combine them into one radical expression. 1. Express the product of multiple radical expressions as a single radical expression. 2. Simplify. Example 3. Using the product rule to simplify the product of multiple square roots. Simplify the radical expression. Square root of 12, square root of 3. Solution. Square root of 12, 3. Express the product as a single radical expression. Square root of 36. Simplify. 6. Try it number 3. Simplify. Square root of 50x, square root of 2x, assuming x is greater than 0. 1.3.3. Using the quotient rule to simplify square roots. Just as we can rewrite the square root of a product as a product of square roots, so too can we rewrite the square root of a quotient as a quotient of square roots, using the quotient rule for simplifying square roots. It can be helpful to separate the numerator and denominator of a fraction under a radical so that we can take their square roots separately. We can rewrite square root of 5 over 2 as square root of 5 over square root of 2. A. The quotient rule for simplifying square roots. The square root of the quotient a over b is equal to the quotient of the square roots of a and b, where b is not equal to 0. Square root of a over b equals square root of a over square root of b. How to? Given a radical expression, use the quotient rule to simplify it. 1. Write the radical expression as the quotient of two radical expressions. 2. Simplify the numerator and denominator. Example 4. Using the quotient rule to simplify square roots. Simplify the radical expression. Square root of 5 over 36. Solution. Square root of 5 over 36. Write as quotient of two radical expressions. Square root of 5 over 6. Simplify denominator. Try it number 4. Simplify. Square root of 2x squared over 9y to the 4th power. Example 5. Using the quotient rule to simplify an expression with two square roots. Simplify the radical expression. Square root of 234 x to the power of 11 y over 26x to the power of 7 y. Solution. Square root of 234 x to the power of 11 y over square root of 26 x to the power of 7 y. Combine numerator and denominator into one radical expression. Square root of 9x to the 4th power. Simplify fraction. 3x squared. Simplify square root. Try it number 5. Simplify. Square root of 9a to the power of 5 b to the power of 14 over square root of 3a to the power of 4 b to the power of 5. 1.3.4. Adding and subtracting square roots. We can add or subtract radical expressions only when they have the same radicand and when they have the same radical type, such as square roots. For example, the sum of square root of 2 and 3 square root of 2 is 4 square root of 2. However, it is often possible to simplify radical expressions, and that may change the radicand. The radical expression square root of 18 can be written with a 2 in the radicand as 3 square root of 2, so square root of 2 plus square root of 18 equals square root of 2 plus 3 square root of 2 equals 4 square root of 2. How to? Given a radical expression requiring addition or subtraction of square roots, simplify. 1. Simplify each radical expression. 2. Add or subtract expressions with equal radicands. Example 6. Adding square roots. Add 5 square root of 12 plus 2 square root of 3. Solution. We can rewrite 5 square root of 12 as 5 square root of 4 dot 3. According the product rule, this becomes 5 square root of 4 square root of 3. The square root of 4 is 2, so the expression becomes 5, open parenthesis, 2, closed parenthesis, square root of 3, which is 10 square root of 3. Now the terms have the same radicand, so we can add 10 square root of 3 plus 2 square root of 3 equals 12 square root of 3. Try it number 6. Add square root of 5 plus 6 square root of 20. Example 7. Subtracting square roots. Subtract 20 square root of 72 a cubed b to the power of 4 c minus 14 square root of 8 a cubed b to the power of 4 c. Solution. Rewrite each term so they have equal radicands. 20 square root of 72 a cubed, b to the power of 4, c, equals 20 square root of 9, multiplied by square root of 4, multiplied by square root of 2, multiplied by square root of a, multiplied by square root of a squared, multiplied by square root of, open parenthesis, b squared, closed parenthesis, all squared, dot, square root of c, equals 20, open parenthesis, 3, closed parenthesis, multiplied by, open parenthesis, 2, closed parenthesis, a, b squared, square root of 2a, c, equals 120a, b squared, square root of 2a, c, 14 square root of 8, a, cubed, b to the power of 4, c, equals 14 square root of 2, multiplied by square root of 4, multiplied by square root of a, multiplied by square root of a squared, multiplied by square root of, open parenthesis, b squared, closed parenthesis, all squared, multiplied by square root of c, equals 14, multiplied by, open parenthesis, 2, closed parenthesis, a, b squared, multiplied by square root of 2a, c, equals 28a, b squared, multiplied by square root of 2a, c. Now the terms have the same radicand, so we can subtract. 120a, b squared, square root of 2a, c, minus 28a, b squared, multiplied by square root of 2a, c, equals 92a, b squared, square root of 2a, c. Try it number 7. Subtract 3 square root of 80x, minus 4 square root of 45x.